Hi everyone and welcome back to my YouTube channel. In this video, we are going to create our RTC client or WebRTC client. So to do that, let's create an interface called RTC client. Just like that. These RTC clients will have a PeerConnection object of type PeerConnection. And it has some functions. First one is onDestroy. Next one is call, answer, function on remote session received. It will get a session description as input. Fun add ICE candidate to peer, which gets an ICE candidate from us. And also fun send ICE candidate to target or peer. Doesn't matter. It gets the ICE candidate and also the targets. So this is our client, and we will have an implementation of this class called RTC client implementation. Like this, it's going to implement the RTC client. It's going to get a connection as the input, username as the username, target as the target as the guy who wants to interact with this JSON object for sure. A listener of type WebRTC signal listener, which I'll create in a second, like this. It will have a message model in it. So we'll have this WebRTC signal listener, it can be null initially, and also a callback of type destroy client, which will return a unit. So down here, we'll override the PeerConnection and set it to the connection that it receives, and then implements all other members of this class. So this client is only responsible for establishing a connection to the other peer. That's the only reason that we have created this RTC client. On the other hand, we will have a WebRTC factory that is in charge of instantiating the PeerConnectionFactory, the PeerConnections, and other stuff. So let's create the WebRTC factory, and then we'll come back to this RTC client later. So this WebRTC factory is going to be singleton, and it's going to be injectable with the constructor. It will receive the context and the JSON object. So right now I'll copy and paste the functions that I'm going to write. So first thing to do is a function that initialize our PeerConnectionFactory. So we will have the init function that receive the local surface view type surface view renderer. In this function, we will init PeerConnectionFactory using the context. So after initializing the PeerConnectionFactory, we want to create a method that provides us the PeerConnectionFactory, not initializing. So to do that, we will add the function create PeerConnectionFactory. It's going to return the PeerConnectionFactory builder, set up the video decoder and encoders, and also add the options, which is going to be these two, and then create the PeerConnectionFactory. But first, let's create that WebRTC variables section, and then we will create private val EGL base context. It's going to be EGL base dot create dot EGL base context. Okay, so right now, if we see this init, it means we want to start our local streaming. So to do that, we will call a function init surface view. Let's rename this. So let's copy and paste it init surface view below here. So we first instantiate our surface view renderer, and using init block, we will start our surface view renderer to be able to start working for us. And then we will start the local video. So the local video is actually going to create a surface texture helper, and using the video capturer, which I'll create up here, and instantiate using get video capturer, which is going to be this function. It will provide us the camera to animator class and create our capturer. And then let's go back up there and create this local video source, audio source, and video tracks variables. And down here, we do have our local video source, and we're going to need our PeerConnectionFactory object like this. PeerConnection is being created by lazy, so whenever these one are getting used, the PeerConnection is going to be created. So we do have our local video source and local audio source, and also our local audio track, video track, and local stream, and their IDs. So down here, we will create our video capture, initialize it, and then start the capture. These are the dimensions of the camera that we are going to record, and this one is for the frame per second or FPS. After that, we will create our video track and add it to the surface that we are using as the local, and we want to use the front camera. This one is actually additional. You can remove it and add the functionality of switch camera later to this WebRTC factory. And then we will create our local audio track, and after creating the tracks, we will create our local stream and add the tracks to the stream and make everything ready for our local stream to be added to a new PeerConnection. And this local listener is actually because we want to update our view model and our call service to let it know that, hey, there is a local stream ready, so you have to preview it inside the UI. So we have to add a listener to this class like this. It will have the WebRTC media stream, and inside the WebRTC factory, we will add the listener like this, and we will store it right here and store it as a local variable. So up here, the listener. So whenever the local stream is ready, we want to notify the higher layer that is going to use this class. So right here, I want to add two functions. The first one is on this row, which is for the time that we close our application. We want to destroy everything. We want to local stream dot dispose. Also video capture dot dispose. And another function which is going to be private, destroy current process, which also use the run catching, and using video capture dot stop capture and dispose it. We also want to use it up here as well, stop capture. So the next function is actually going to be the main function that creates an RTC client for us. So fun create RTC client. It's going to get an observer of type PeerConnection dot observer, a target which is going to be string, and a listener of type WebRTC signal listener. It has to return an RTC client, a nullable RTC client, and we have the body here. So first, we have to create a connection using PeerConnectionFactory, create PeerConnection. We simply want to pass PeerConnection.RTC configuration, pass the iServer, which I do not have here, apply a block to it, and enable CPU overuse detection and set it to true. This one will optimize reducing the quality or improving the quality whenever the CPU resource is not available or it's available. And also pass the observer to it. So let's create this iServer object. Since I'm not using any kind of global variable at the moment, I'm going to simply just use this empty iServer list. But later you can create your iServer as I taught you how to do it inside my YouTube channel. You can add it up here to this list, and then using the connection, we want to add the stream and pass the local stream to it. Then return if connection is not null, an RTC client's implementation, pass the PeerConnection, my application.username, target, JSON, and the listener. And for the callback, we simply want to pass the destroy current process. So this WebRTC factory is actually ready to pop up an RTC client, which is going to be RTC implementation client. So let's go back to our RTC implementation class and handle what we want to do here. Forgot to add unit here. Okay, so up here I want to have a media constraint object that has some key value pair object in it, which wants to offer to receive video and audio. And let's start with the call function. We want to use that PeerConnection objects and create an offer. And for the observer, we simply want to use an object of my SDP observer to avoid boilerplate code, which I'll add it here. You can see it's an open class, and implementing of these functions are optionals right now. So let's go back here and create this one. As you can see, it doesn't want us to implement all the members right now. So for now, we just want to implement the objects that we need. And for the media constraint, I'll simply pass the media constraint to it. So right here, I want to know whenever create success is being happens. So whenever a create success is being happens, I want to use PeerConnection and set local description to it. And for the observer, I do again use my observer class. And for the session description, I'll simply pass the description to it. And inside here, I want to know if the local description is being set successfully. So I'll override on set success here and use the listener, and on transfer event to sockets, I simply want to create a message model. Data type is going to be socket events.offer. The name is going to be our name, username. The target is going to be target. The data is going to be description.description. Actually, this one is type, and yeah, we are good to go. So here is our call function. Each RTC client can use this call function, whose the target is. So you will use this function and call the target. And it's almost pretty much the same for the answer, which I'll copy and paste it here and explain to you. So it creates an answer, and for the observer, pass the mySTP observer class. And whenever the answer is created using this function, we will set it inside our local description first, and then notify the other client that, hey, I'm sending you back an answer with this description. And for the on remote session, we want to use PeerConnection and set remote session description, pass my STP observer, which we do not want to observe anything, and pass the session description to it. For add ICE candidate to peer, we simply use PeerConnection and add ICE candidate to it. And here I'm wondering, why is this target we want to string like this? So for the send ICE candidate, first we want to add ICE candidate to our peer like this, and then using listener and transfer some data to opponent. So we will create a message model. The type of it is going to be socket events.ice. Name is going to be username. Target is equal to targets, and data is equal to JSON.toJSON, and pass the candidate to it. And the last one is going to be on destroy, which we will close our PeerConnection and then destroy clients, which is this callback. So let's remove this val object. So right now we know how to instantiate our PeerConnection factory, initialize it, create a PeerConnection factory, start our local stream, and start capturing. And then we know how to create an RTC client, which is this class. And this one is responsible to start a call and establish the connection, and also all the required stuff that is being necessary for creating a video call. So that's it for this video. On the next video, we will learn how to use signals that, hey, there is a new user being joined to the room. We have to start a peer connection to this user. So on the next video, we will learn how to establish a new connection to the user, hold the state of the connections, and start showing the media stream of the opponent. Till the next video, see you everyone.